How is it going, ladies and gentlemen? This is the Wolf Around, and it's great to see you here. This is the second video of my cross-platform CUDA hardware acceleration series. Most of time, setting a requirement in Linux can be extremely confusing. I prepared this video to show you the smoothest way to set up CUDA on Linux. Subscribe to the channel, join the pack. You are always welcome here. By the end of this video, your development experience will be enhanced, and CUDA will be installed on your Linux machine. Without further ado, let's get started. Right now you can see several open tabs in the browser with important documentation. We'll inspect these together. First, let's look at the release notes of CUDA. Before installing CUDA, you should always check the required driver version for the CUDA version you want to install. For CUDA version 12, your driver version should be higher than 525.60.13 on Linux. And on Windows, it should be higher than 528.33. Alright, let's verify the version of the currently installed NVIDIA driver. Open a terminal and type NVIDIA SMI. Wait a second. It says NVIDIA SMI command not found. This means the NVIDIA driver isn't even installed. Linux distros use the Nouveau driver for NVIDIA GPUs by default. In my opinion, Nouveau is not useful for anything else than keeping the screen alive. Installing the real NVIDIA driver is always the best choice for many aspects like lower power consumption, higher performance, and compatibility. Before installing CUDA, we are going to install NVIDIA drivers for Debian 12. I choose Debian for this tutorial because it's low level yet powerful. Learning it professionally will improve your Linux skills significantly. Let's also review the CUDA Linux installation notes to ensure compatibility. First, we'll check the Debian version. It's Debian 12, so that's fine. Now let's check the kernel version of it. The kernel version is fine too. Let's check the version of C++ compiler. By the way, remember that you need a solid C++ development environment already set up. You can watch my video on setting up the best C++ development environment on Linux. There is a link at the top right corner. Everything looks promising. C++ compiler version is okay too. And lastly, let's check the version of the GNU C library. The GNU C library is a core part of the Linux kernel. You can't change it unless you change your Linux distribution or your distribution's developers update it. Alright, with all requirements checked, we are ready to install NVIDIA driver on Debian 12. Now I'll summarize Debian's NVIDIA driver page. According to this page, we can install version 535, which is compatible since it's higher than 525. Let's confirm that Debian recognizes our GPU. Use this command. It should list your GPU. Next, we'll install the NVIDIA driver using the apt package manager. NVIDIA drivers are in the non-free section of Debian distribution. To access the non-free section using apt package manager, we need to edit a special file which is named as sources.list. I'm going to use Nano Terminal text editor to quickly edit sources.list file. Open this file using Nano with root privileges. Delete everything in it, then copy and paste these entries from the Debian NVIDIA driver page. Now let's update the apt package index. Then we'll install the NVIDIA Detect application. We wouldn't be able to access this application if we didn't update the sources list. NVIDIA Detect will approve that our NVIDIA GPU is not too old for the currently available driver version. It says OK. Now let's install NVIDIA driver using apt package manager. This blue-colored warning screen brings good news. It says you'll get rid of the Novo NVIDIA driver. You just need to reboot your computer to start using the actual NVIDIA driver. Hit enter to say OK. Now let me run NVIDIA SMI again. This time we could run NVIDIA SMI, but it says it couldn't access to the NVIDIA driver. Let's reboot the computer. After reboot, we will move on together. After rebooting, let's check our installation by running NVIDIA SMI again. Great, everything is as we expected. Now download the correct installer for your Linux distribution. I'll download the local installer for Debian 12. First, we'll create a directory for the download. First installation command tells us to download the local installer using wget in the terminal. The download is complete, so now we can start the installation. The second command installs the downloaded CUDA package using Debian's package manager, dpkg. This package manager is available for all Debian-based distros. The third command copies the CUDA repository's caring file to the suitable directory. The fourth command adds the contrib repository section, allowing the installation of additional software packages that are not part of the core Debian distribution. Actually, we added the contrib section when updating the sources.list. I could use this command easily to add non-free section, but as an experienced software engineer, I want to share my knowledge with you to help enhance your skills. Now you know what this command does in the background. If you find my content helpful, please consider liking and subscribing. This channel is still young, and your support will help me create more content like this. Join the pack. You are always welcome here. The fifth command updates the apt package index, and the last command starts the installation. Although CUDA is installed, we still can't run the CUDA compiler directly from the terminal. We have to add CUDA installation directory to LinuxPad. I'll open a separate terminal and show you the installation directory of CUDA. As you can see, CUDA is installed at this directory. We'll add some folders to LinuxPad to finalize the installation. Open bash rc file in nano. Go to the end of file and add the lines I'm typing. I'll share these lines at the video description, but make sure to edit version numbers with your preferred CUDA version. Open a terminal or refresh the current one. Then run this command. This time, you should see the version number of CUDA compiler. Let's print Hello World using the cmake project setup from the previous video, where I showed you how to install CUDA on Windows and set up a cross-platform CUDA project using cmake. If you are curious about creating a project using cmake, check out the link at the top right corner for that video. For now, I'll briefly explain the contents of main.cu file. Here, we include iostream for input-output and CUDA runtime.h for CUDA functions. The global keyword indicates that the function will run on the GPU. Using printf function within a CUDA kernel is mostly for debugging. The CUDA device synchronize function ensures that the GPU has completed its tasks before the CPU proceeds or exits. And last lines print the device computing capabilities. Now I'll compile the code. Open a terminal and navigate to the directory with cmake list.txt. First, I'll generate the build system files. This command uses the cmake list.txt, which contains this project's configuration. Cmake detects the CUDA compiler and C++ compiler. Now let's compile and run our Hello World CUDA program. I got an error because I forgot to edit the cmake configuration. The lib extension is Windows specific, so I'll remove it and try again. Now let's run the executable and see the results. Thank you for watching till the end. If this video was helpful, please like and subscribe. I'm a software engineer specializing in computer graphics and cross-platform C++ development, and I look forward to sharing my experiences with you. In my next video, I'll dive deeper into advanced CUDA topics. Stay tuned and I'll see you in the next one.